Hi guys, Mark Millett from Solar World. I'm here to demonstrate a battery build on a GM lithium volt 24 volt system. It will be what's called a 6S BMS battery management system. So what I have here are one of the control modules. We'll have to add this onto every 24 volt pack. This is for safety. What this does is allows the system to charge with the PV system or any other type of DC above the nominal voltage of 25.2. It's called the 6S because it's 6 series, each volt nominal at 4.2 volts. Lowest point will be 3.5 volts. This will allow for safety of shutoff and charging without having any disruption between the cells. I want to talk quick about battery technology. Old battery technology, everybody knows. Lead acid, been around, durable, cheap. But the problem is you just can't get more than 50% of the cell to discharge safely. The reason why is because it's lead acid and it's chemical based and so forth like that. But it also needs to vent. These are what's called sealed lead acid batteries. They do vent a little bit, but under high pressure. So they're able to take a higher voltage to be able to, last longer. But the problem is I can only get roughly out of this 9 amp hour battery, roughly 35 usable watts. That's pretty heavy when you're adding multiple cells like this. Or even if worse, you're using golf cart batteries. The problem with those, you're able to charge them and discharge them, but they vent hydrogen gas. So, you need to have them in a ventilated area. And they're heavy, and they only last, 400 usable watts out of each battery. So that's not good for solar. So I started experimenting and found this DIY kit, you can build online and so forth. It worked out pretty good, not bad. I got about 350 usable watts out of this bad boy, and this only weighs 12 pounds compared to, let's say, 60 to 80 pounds for a normal lead acid battery. So this is pretty interesting. This is Tesla-inspired 18650 batteries, somewhere around 2200 milliamp hours each. So when it comes down to it, I have about 7 watts per cell, and I can discharge those 80%. So I roughly have maybe 5.5 watts per cell. I have 49 in this bank here, and the awesome thing about this is same type of, sorry for the lighting here, same type of BMS. This is a 25 amp, I believe. Anyways, the point is, under testing, this did quite well. Cost efficiency, okay. And time consuming building. I love doing this type of stuff, but at the end of the day, we're in it to make sure the efficiency and everything else stands to the bar. The problem is, one of these fail and you have a problem, you're able to repair it pretty quick, but I've encountered quite a bit of failure over a period of time using solar. So I was trying to figure out a different method, of course. Tesla seems to get it down pretty good, but they're using big battery banks. They're using like 8 of these bad boys just for 5 kW. How can I get 5 kW, but not in that flat form? How can I adjust or compensate for any type of application I'm using, and cheaper? That's the trick. So, found a distributor, and we buy these GM lithium volt batteries here that you see. This is a pack right here. So this is roughly 5.3 kW just in this pack right here, as you can see. It's not too big, roughly about 2 foot. This is around 72 volts right now. What we're going to do is we're going to break this down into 24 volt sections, right? That's pretty easy to do. Don't be discouraged about this. And once it's broke down, you'll have this awesome little protection between each cells, right? And because there's a cooling jacket and all this other awesome stuff that goes with this pack, we're breaking it down into what's called the 6S. So you have 1, 2, 3, 4, 5, 6. You just count your lines going across, find your negative or your positive end of the terminals, and then you just start the series. And what I did was I went ahead and cut one of these in half to make this last end of the series work. So this registers at 25.2 volts. This has roughly about 1,200 usable watts, roughly almost 3 times the value of what a lead acid battery can do. I can charge and discharge this thing somewhere around 2,000 times. Lead acid battery, you're lucky enough to get 250. See the difference? Cost efficiency, it's like 2 of those lead acid batteries and weighs less than 40 pounds. So today we're going to go ahead and take our tool list of materials and stuff that we need to do. So here we have one of the packs already broke down. This is a nominal voltage of 3.5 volts, 4.2 on the high end, 4.25 actually. So what I did was I went ahead and taped this up just to make sure. I have kids rolling around, don't want anybody to get hurt, so forth like that. Safety, oh my God, I cannot preach anything more about safety with these damn things. They've scared the living crap out of me. I've dealt with this stuff since I was 14 years old. I've never encountered lithium power with this much amperage. 200 amps out of 3.75, and it's still just anyways, be careful, please. So, as you see, we have our wire cutters. We have our BMS connection wire. This all comes in a kit. Once you're done, after soldering and installing this to the battery, you plug that in. Very simple. We have a 1/4-inch drill bit. I don't know if you can see that very well. Anyways, 1/4-inch drill bit. We got one of these bad boys right here, and what this is just a bus clamp. Holds the wire, and I'll show you what that does in a little bit. And the corresponding nut and bolt to go with this outfit. As you can see, what I like to do is, extension cords hate me. I grab extension cords. They come with negative and positive coating wire, heavy duty up to about 20-25 amps. We are not using that for this charging application, so we're able to get away with this. A couple zip ties, as you can see, and a sharp utility knife of some sort. Basic hand tools. So we're going to go and start the process real quick here. Get your soldering gun out right away. All right, I have mine ready. It's already plugged in. There we go. All right. Get your solder out. Since I have mine hanging above the battery, all dangerous like as it is. You go have your solder. On your BMS, you have a incoming and outgoing power, or vice versa. Just make sure and read the little diagram that's on this bad boy. It's pretty simple. All right. So we're going to go ahead and put our outgoing power. What I like to do is strip the wire down right away. Stick it through the hole. Giggity. Twist it. Make sure you have a nice tight connection. You see that? All right, good. So, and then from the back side of the BMS, you'll have this flat spot of weld that you're able to go ahead and adhere this wire to. Get that done. Also during this time, while I'm heating up the gun here because it takes a second, extension cords. They're going to be your best friend. So you're going to have to strip this down for the other side of the BMS in just a second here. While this is heating up. You could just go like this. Make it automatic. Yeah, that works, right? Did I say don't try this at home? Zip tie, keep it on. All right. All right, nice and hot. Got it there. All right, while that's heating up, grab a utility knife. Strip down the wire at least 3 inches of a 1 inch or 1 foot cord. Strip it. Out the wires. All right. Once you're done there, get rid of the ground. We don't do that right now. Nice and clean. Let's see, we're going to hook up the BMS wire to the negative incoming power. This would come from your PV array or whatever. And the same thing. Maybe I could strip down just a little more, but strip that down. Put that in there. Twist it like we did before. Nice tight connections. My gun's been sitting here warming up. We should be ready to go. Go ahead and get your solder ready. If you don't know how to solder, you need to learn. It's pretty basic. It's not that hard. My guns are old. That's why I got the safety gate out. You hear that, kid? Man, dude, earlier, he came in here and stuck a knife across the top of this battery. It arced, scared the living crap out of me. That's what I'm saying. Be careful.